What's going on, guys? My name is Amos and I'm back again with another video. I think this is part 9 of our implementation of the most awesome automata theory library, which is AutonLib. So in the previous video we looked at how we can we implemented the function to generate JSON files. Okay, so we're printing information about the automata about the automaton to in a JSON format, and we're writing that to a file. So this is the file that we had, in the previous video, right? So this is the file we had where we wrote the number of transitions, the number of symbols, then we listed the alphabet. We put that in an array. Same thing for the states, same thing for the initial states, and then we have an object of transitions. So probably later when you give this information to some Web2, then it will be able to generate the graph of the automaton that we have here. Now in today's video I just want to talk about the dual API strategy. So if you look at what we did, let me just go back to my header file. Now our header file is like it's our interface, so it provides all the functions to whoever will be using this library later. It provides all the functions, right? So all these functions that are in this header file are public, right? All these will be exposed when the person who's going to be using this library includes this particular header file. And by the way, this is going to be a shared library, so meaning we are later on going to get rid of this main.c. For now we're just using it to test our functions and all that, but we'll be able to get rid of this main.c. It's a shared library. There will be no entry point. Basically they will have to include the header files, right? So if you look at these two functions that we have, autonGenerate.file and autonGenerateJSON file. So this is like a higher level implementation of the logic that we have here, because here we're just providing the automaton and then we're just providing the file name. Notice that we're handling the opening of the file. We're also handling the closing of the file, so the user doesn't have to worry about closing or opening the file or anything like that. All they have to do is to pass in the name of the file, then the function is going to take care of all of that. But then we cannot predict, or this is sort of like restraining them to this higher level implementation of generate.file and generate JSON file. Some people might want to just like might want to do different things with this. With this logic, they might not they might write it to some other stream, for example, and they might also want to like close the file on their own. They might also want to like open the file on their own, so they might want to do different kinds of things. So some people want to have control over this particular over what this particular function does, in that they control when they open and when they close, or when they give access to to external resources such as files, for example. So what I want to do here is to provide both implementations. So a higher level, some sort of like higher level implementation of the two functions, autonGenerate.file and autonGenerateJSON file, and also provide some lower level implementation, right? So that they can also do whatever they want. Maybe just provide a pointer to some stream, and then they'll be able to write information about the automata to that particular stream, right? So what I want to do here is we'll make a few changes here. We'll come up with a some sort of like low level implementation for each of these functions, autonGenerate.file and autonGenerateJSON file, and then we'll have the higher level implementation calling the lower level implementation, right? So in case you are confused and you are lost, what I'm trying to say here is we're going to have two functions. So I'm just going to say void, and we'll say autonGenerate dot file. Maybe let me just say autonExport dot, maybe we'll just say dot stream, like so. And then what we need here is, well, we'll need the automaton, because we'll have to like write the information about the automaton to some file or to some stream. That's what we want to do here. And then we'll say automaton, like so. But then instead of like passing in the file name, they'll pass in a pointer to some file. So I'm just going to say fp. So this is like our lower level implementation, right? This is our lower level implementation. Now we'll do the same thing for the other function here. We'll do the same thing. So if I like, okay, let me just do, so we'll have void the same thing, and then Auton, let's say export dot JSON stream. We'll just say JSON stream like so, and then grab the the pointer to the automaton whose information we want to print. So we're going to go automaton like so. So it will have the same signature as as the Auton export dot stream. So it will have the same. So we have like automaton, and then we'll also pass in a pointer to some file stream like so. So you see that this is a lower level implementation because we are giving them the chance to, or the possibility to open the file on their own, and then also close the file on their own. All we're going to do here is provide the logic for writing the information to some stream or to some file, right? How they close their file, how they open their file, we don't care, right? So this is what we are doing here. So this is a low level implementation, right? Because if you look at the other two functions, we are closing the file and opening the file on their behalf. They're just passing in the name of the file, right? So what I want to do now is, first of all, let me just prototype these two functions. Let's make this available, because this is our interface. Let's make this available. So I'm going to like put this in my my header file, and it doesn't matter where you put it. I'm just going to put it above the two functions. So we'll have that. Now I'm going to make a few changes here. I'm going to make a few changes. So all the logic, I'm going to like give it the lower level implementation. Then the high level implementation is going to call the lower level implementation. That's what I'm going to do here. Now, before we even do anything, remember what we're always doing here. We have to assert the arguments. We have to assert that the arguments are not null. So I'm just going to throw in the automaton here, I believe. Automaton, okay. So I'm going to throw that automaton here, and then we'll also check if fp is null. So after this step, now we can copy all the logic. So this is the dot stream, right? So I'm just going to copy all the logic that I have just I think just below this below this particular logic for opening the file. I'm just going to grab all of this. I'm just going to grab all of this because we already have a pointer to the file, right? So I'm going to grab all of this, and grab all of this, and I'm going to say Control X, and that is going to handle. And I will probably should have okay, we will delete it from here. So dot stream, okay, we paste that, and we're not interested in like closing the file, so we'll remove that. So okay, we print, right? So we print the information, and we probably have a few changes to make here. So I want to replace this this dot file here. I'm just going to say fp, and I'm just going to copy that, and probably I probably should have just maybe renamed this to, it would have been a lot easier. And what we just have to do now here is to pass in the file pointer. Oh, can we actually do this? Can we refactor? Can we rename this? So refactor, no, it doesn't. Okay, let's try rename symbol. What does rename symbol do? Let's say fp. If I say fp, does it? No, it doesn't do anything. Okay. Okay, so let's continue with our copying and pasting. I know there's a better way of doing this, because this is going to take a lot of time to do. So I'm just going to say Control V. Now, is there like a rename or something that can, so um so I'm just like getting rid of the dot file that we have here. So I just need something that is more generic. I think dot file is more specific. We just want them to provide a stream, the file stream, right? So I think so this so we've given the logic to this lower level implementation. We've given the logic to this lower level implementation, and then in the other function, um, we're going to call this auton export dot stream. We're going to call it here, right? So we assert that the automaton is not null. We assert that the file name is not null, and then we open the file. And since we've opened the file, we also have to like close the file. Okay, close the file. Now here I just want to say close the file, and we're going to say, is it dot file? Right, dot file, right? Okay, like so. And then here we're going to call the low level implementation. So we're going to say auton generate dot stream, like so. Now what do we need? Well, we're going to, provide our automaton here. And then what else do we need to provide? We need to provide a pointer to, to file. So we're going to say dot file, and that should be it. So you see, we're providing, the two implementations, so they can choose whichever one whichever implementation they want to use, and everything should be okay, right? So for the first implement for this one, auton export dot stream, we don't care, we don't care how they manage their files or their external resources. We just provide the logic to write the information about the automaton to some stream. So this is what we're doing here, right? So yeah, that should take care of that. So I'm going to like collapse that, and let's do the same thing for auton generate that. Okay, and before doing anything, I think what I should do here is mm, 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 mm. Can we like rename this or something? So renaming is doesn't allow refactoring. Well, what about rename? Do we have some rename somewhere here? There's only rename symbol. Refactor doesn't work. Rename symbol. It looks like it's going to work now. Okay, let's say FP. No. Okay, let's say FP. Does it change? No, it doesn't. Gives a prompt here. So it tells me to, erase. Okay, let's say apply. Okay, it does. Okay, so we have FP, right? And I'm going to like feed this to the low level implementation, the logic. So let me just see what we need here. So we have an FP, which is good. We have an FP, so we don't have to worry about opening the file. Right, so we grab that, grab everything. Yeah, so up to this point. So I'm just going to say Control X, and I'm going to paste it here. Auton export JSON stream. So we just have to check that we are, writing everything to the. So what we have an error. Let's see the error. We have JSON file here. So we must have FP, I think. Yeah. So let's do FP here. Same thing here. Let's do FP. How many FPs must we have? Generate JSON file. Okay, FP. Let me just copy this because I know we didn't do anything. So FP, like so. FP. I just have to bear with me. I know at the end of the by the end of the in the next video, I'll like try to find ways of like renaming things automatically and not like doing everything manually. So you just have to bear with me. I'm just going to like Control V, Control C until we get to the very end of this. Okay, so I'm just like replacing. We need to delete that, and Control V, Control V, Control V here, another Control V I think here. So we've actually made changes in a lot of places. We probably have to test this. So FP like so, and then FP, very long function. So FP, and remember I said we're going to refactor and probably split this into multiple functions. Yeah. So Control V like so. We have a lot of things to change. So Control V, and we also have to make changes here until all the errors disappear. Control V. I think if you are watching this video, maybe you can just be fast forward this video or something to, so that I do not waste your time with my Control V, Control C. So Control V, yeah, that should be, no, we still have, forgot about this. Okay, Visual Studio is no longer complaining, so everything looks good. Okay, so we write, we start that. We probably have to, here we have to asset that the everything that we have here is not no. We have to asset our arguments here. Same thing, asset, and then FP, I think, yeah, FP. That should be it. That should be everything. Yeah, that should be everything. That should be everything. We've replaced everything. Let's. Okay, that looks good. So let me just collapse that. And here, again, instead of saying that, I'm just going to go rename symbol. You really let me down the last time, so I'm just going to say file name. Yeah, apply the changes. Okay, that works. And we've opened the file here, and now we can call our low level implementation. So auto export JSON stream, provide the automaton like so, and then provide the JSON file as our file stream. Great job. So this is what we have here. This is what we have, right? So this is what we have. So the higher level implementation looks okay to me because we're opening the file and then closing the file for them. Here, we're not doing anything. Okay, we're not doing anything. They'll just pass, they'll just provide a pointer to the file, and then we do the assertions here and then just write the information. We're not even going to close the file for them. They're going to close the file themselves. Okay, so that's the high level implementation. So we've made a lot of changes, and I really want to like see if our code has, if we have errors, if let's try to compile everything. Let me just go back to our main, and let me just see what we have. Let me just get rid of this JSON thing that we have here. Let's compile the program. Oh, actually, it's mingw32, right? Oh, so it's ming w32 make no targets found. We have to go into we have to cd into the build folder. Yeah, we have to see probably it's this terminal I was using. Yeah, so we have to like cd into the build folder because that's where the make file is. Okay, I think we have no errors. Do we get a segmentation fault? Probably. So let's we have an executable. Let's run it on lib like so. It generates the JSON file. I think everything is good. Okay, yeah. So That's all I had for this video. I'll see you in the next one.